Let P and Q be polynomials. We want to find the limit as x approaches infinity of P of x divided by Q of x if the degree of P is A less than the degree of Q and B greater than the degree of Q. Well, the first thing we need to do is we need to define what P of x is and what Q of x is. So we can say that P of x is going to be A subscript n x to the n plus a subscript n minus 1 times x to the power of n minus 1 plus and so on. And so therefore the denominator is a polynomial q of x. We can say that this is b subscript m x to the m plus b subscript m minus 1 x to the m minus 1 plus and so on. Okay, so what we're concerned is a degree of P less than the degree of Q. So we're only going to look at the first terms of each polynomial. So here we're looking at a subscript n x to the power of n divided by b subscript m times x to the power of m. So now what we want to do is we're looking at the degree of P is less than the degree of Q for part A. So what is the degree of P of x? Well, we know it's n. What is the degree of Q of x? Well, we know it's m. We want to find out when n is less than m. Now, if we subtract n to both sides, then we get 0, and then this becomes m minus n. Or we can say that this is m minus n, which is greater than 0. So now what we're going to do is we're now going to take the limit as x approaches infinity of a subscript n x to the power of n divided by b subscript m x to the power of m. Now, if you look here, if we have the same base, we want to get to the point where our exponent says m minus n. So that means that we need to rewrite this so that x to the n is going to be in the denominator. So when we rewrite that in the denominator, think about what happens with your exponents in algebra. So that means that what we can do is get the limit as x approaches infinity of a to the n divided by b to the m, and this becomes x to the m minus n. So now that's what we have in the denominator. X is to the power of m minus n. So what do we know about m minus n? We know it's greater than 0. So if that's greater than 0, then what that tells us is that that is going towards positive infinity. So if we apply this limit, then we get a subscript n divided by b subscript m to the power of infinity, which is going to equal 0. Now let's take a look at part B. Okay, in part B, we want to see if the degree of P is greater than the degree of Q. So that means in this scenario, we're looking for when n now is going to be greater than m. So if we subtract m to both sides, then we get n minus m, which is greater than 0. So now let's go ahead and take a look at the limit. So the limit as x approaches infinity of a subscript n x to the n divided by b subscript m x to the m is going to equal the following. The limit as x approaches infinity. So what we're going to get now is a to the n divided by b to the m. And so we want to have now m to be a negative exponent. So we're going to bring that up to get x to the n minus m. So when we evaluate this limit, then we get the we get a subscript n divided by b subscript m times infinity. Okay, so what that means is it's going to be approaching positive infinity, or it also depends on the leading coefficients, because the leading coefficients, one of them can be negative and the other one can be positive. So that means not only is this going to be approaching positive infinity, but it can also be approaching negative infinity. So let's just go ahead and review this again. So we saw that when the exponent m minus n was greater than 0, that turned into infinity. So we divide this by a denominator that's approaching infinity, and that gave us 0. And then here, when n minus m was greater than 0, then we brought the x up to the numerator, and so that gave us infinity. And so we know that depending on the leading coefficients, it can approach positive or negative infinity.